Hello Internet, welcome. Today I'm going to learn about a language I know nothing about except for like vague osmosis knowledge about it. It's going to be Racket, which is a language that does, as far as I know, functional programming most of the time, but as I've heard, it's multi-paradigm and does more stuff than that. And I also heard like excellent recommendations about building other languages with that. In the background, we have people that might join in if they choose to, but only if they choose to, basically. So first of all, I have the Wikipedia page of this language right here. I think I will just read it shortly. And after that's done, we will actually get to some running code, and maybe we'll try to solve some problems with Racket. One more minute before we actually start. I'm going to close the window. There's some noise here. And let's go. So Racket, general purpose multi-paradigm programming language, multi-platform. Okay, it has a large standard library. That's interesting. I was thinking probably like languages that are like, I thought this language will be lean, but we'll see how big the standard library actually is. Modern dialect of Lisp. What runtime does it use? Does it have like its own runtime, or is it like a JVM based language, for the JIT? Doesn't say here directly. Development. Let's talk about the lore. Let's actually go for the features. So it has macros, modules, tail calls, delimited continuation. Okay. Basically, your just a language. Let's look at some code examples and let's see if I can actually figure out how things work. So lang bracket hello world. So evaluating strings prints to standard output. I'm quite surprised by that, but we'll learn in a minute. What else do we have here? So apparently there's an image library or some image library, and we have a Sierpinski triangle with 8 layers of recursion. Is this actually 8 layers? 1, 2. Sorry. 1, 2, 3. Yeah, okay. I will believe them. This is actually 8 layers of recursion. Anyhow, okay, so it's really good for like simple graphics. Interesting. Taken from the Racket website. Draws the basic triangle. Length type Racket. Fact integer. So fact is the argument name, and this is the signature of the function, which accepts one integer and returns one integer. Then we go for factorial. Yeah, okay. Seems simple enough, like to actually implement that. I think we can let's just play with that like locally somehow. So let's bootstrap this. So we can take our terminal and let's go for streams. Let's make another directory for Racket. Zoom in, and how do I install a runtime that can work with Racket? So we've got Racket script. Yeah, that's probably not that interesting. So we've got PyRacket on our Python. Oh, I'm quite surprised that our Python is actually being used on not only in like PyPy. So if we go to the website of Racket itself, Racket Lang, do they have like a nice download? macOS M1. Probably fine. I would have preferred like brew search Racket, so I can easily uninstall that. Okay, so we do have Racket as a cask. I'm surprised, but sure. Brew info Racket, just to make sure that's actually the right thing. Racket language, yep. Okay, so we need OpenSSL 1.1 because this language has not working like a sane language. And if you want to build Dr. Racket IDE, you may want to run. Oh, that's kind of nice for them to actually, the full Racket distribution is available as a cask. Wait, so this was not that was minimal Racket. Interesting. So let's uninstall that apparently because I failed to uninstall Racket. Treating Racket as a formula, yeah. And let's install the cask. So this should now download everything, also the IDE, probably. And we should maybe also figure out like what kind of programming problem we'd like to actually solve. So little macros, general purpose, big macros, easy DSLs, IDE support, any syntax. I like the phrasing here. Racket programmers love parentheses, but they have empathy for those who need commas and braces. Oh, that's so nice. That's very that's like the nicest thing people have ever said on like curly braced languages from the parenthesized language community. So I appreciate that. Wow, okay, this installation is actually taking a lot of time. I'm feeling like I'm not doing enough in that time. Should we just go for like lead code easy problems at first and then like solve harder and harder problems with a language I have no information about? But probably this will not teach me a lot about the language, but it will teach me how to use like the basic data structures, which are functions, arrays, and hash maps. Which I think is like kind of a good basic thing to do. So maybe let's actually just do that. So let's go for lead code, not because it's a good problem set, but just because it's good enough to actually like learn the super basics of a language. Do we need to sign in? That's kind of sad. Can we go to just problems? Yeah, we can. So let's go for, first of all, easy problems. And let's just take literally the first one. And if I can just pick Racket here, that means I don't need to do anything. So define contract to some numbers target. Okay. So first of all, like I already see that I am actually confused about the syntax, which means I have something to learn without even thinking about the problem itself. So first of all, let's actually read the problem statement and then try to figure out how do we tackle that with Racket syntax. So example, we've got numbers and a target. Output 0, 1 because sum num1 and num and 0 equals 9. Okay, and we are guaranteed that there's exactly one solution. Okay, can return the answer in any order. So first of all, like the define contract thing is already define contract Racket. Is it just a name, or the fact that there's a slash is something fancy here? So yeah, contract and boundaries. Let's see. Like contract between two business parties, a software contract is agreement between two parties. The agreement specifies obligations and guarantees for each product or value that is handed from one party to the other. The contract thus establishes a boundary between two parties whenever a value crosses this boundary. The contract monitoring system performs the contract checks, making sure that the partner abide by the established contract. In this spirit, Racket encourages contract mainly at the module boundaries. Specifically, programmers may attach contracts to provide clauses and thus impose constraints and promises on the use of exported values. For example, the export specification. Provide contract out amount positive ? So I'm not sure what question mark means here, but we will learn in a minute. So, so that's like
it checks if
I see if the given argument is like it returns a boolean basically, right? It says
and you have one for structures like a list question mark, and it asks if the type is list, or a string question mark if it's string, or a member. No, that is a question mark. But while you have equal with a question mark, you have it's asked.
I see. So that's basically so exact integer. And I still need to like wrap my head around the syntax because, as I said, I'm not familiar with this. But yeah, so we're defining a contract. We're accepting two sums, nums, and target as arguments, and we are returning a callable, which provides us with a list of exact integers. I'm not sure what do we have here. So we have exact integer, a list of integers, exact integer, and another list of exact integers. And if we look at what we actually have here, because like it's all about like carrying, right? So this is like the first argument, that's the second argument, and we are returning this one. Okay. I can get down with that. So let's try to figure out how do we actually write some executable code. So that's the contract thing. Let's go directly into actually Racket. Simple values. I'm starting really, really small. So, okay, so literals are literals. That's not something fancy. Let's go for lists just to make sure. So these are lists. We don't have comma separations. We just separate elements by spaces, apparently. Okay. So if I need to read this again, that's exactly what I have here, right? So no, we don't have an actual list here. I think the arrow is probably like a return thingy, but I'm still like not sure about that. Idan, you may feel free, of course, to like get in and actually.
What is the question?
Yeah, I mean, feel free to jump in if you if you're saying I'm wasting time on something unimportant, but I think like I'm actually trying to learn the syntax. So so we've got Racket essentials again. Let's just go with so we've gone simple values. Let's see simple expressions. So define I3. Define piece string substring string pi. Defines pieces of function of one argument. The argument is string, and it says pi3, yeah. Piece, key, lime, key. So is it splitting by... Oh, I see. Yeah. Okay. Yeah. Okay. That's the function call. Yeah, and the arguments are the object, and then the two other args are actually the thing. And if we go to the definition of this, then we'll see substring, some string, and then two integers, basically. Okay. Cool. So if we try to read that back again here. I still haven't encountered the arrow in this in the syntax. So let's find an arrow.
You can raise that. It's not really important. It's like types in Python.
Yeah,
it defines the contract. You can delete it if you want.
I can delete.
You can delete that line 2.
The whole line.
Yeah.
Oh, I see. So we are passing, but we are passing the argument. Okay, so like define contract itself accepts some arguments, and then anyhow, okay, I'll just ignore.
Matter.
Yeah,
you can ignore it.
So let's try to figure out. Yeah, as I said, I have not written, I think, a proper single line in actual functional languages that do all the bracket thingies. So yeah, hard for me to read, but that's you'll have to sit and grind with me, I guess. So what would I actually want to do here? So I would like to, if we go back to the problem statement, I'd like to actually, is that an O squared thing? This is an O squared problem? Probably not, right? Like there's probably like a proper solution that's not n squared. I mean, the simple solution. I do need to do every pair.
Hash table. You know, like if you know that 9 is 9. If you 9 less than 2 is 7, as you can save 7.
Yeah. Okay, I get you. Yeah. Okay. So yeah, we're trading some memory for doing this quickly, and yeah. So we just need to basically subtract everything. Okay. Cool. So let me write the solution in Python, and then we'll try to translate that to Racket. I'm actually going to literally write this down in Python, and then we'll convert the solution, because I want to do like the language and the algorithms separately. But basically, we've got an empty dictionary, and we like to iterate and for num in nums, dictionary in the place of what was it? Target minus number equals. Do we need to actually store the thing? We don't need. We can do that also with a set, probably.
You should store the index.
Yeah.
Probably.
Yeah.
Before that, you should check if you already have the
like the algorithm itself is not. I will figure out all the problems with the. I want to debug that still in Racket. I want like the bare bones enumerate, and now we've got that, and yeah, so to sum, yeah, and then if we now have number in the dictionary, then we can return I comma what is it? DN. No. I think that's a proper solution. And we are guaranteed this if statement will actually happen. And if not, then raise failure. Oh, I probably just need to run that. I need to, that's very not nice of them. I need to sign in to actually run this, but sure. Let's just do that quickly. So run. Accepted. Okay, so we've got a working solution. And now let's try to figure out how do we actually copy that to Racket. So what, now we can only deal with the translation and not with actually doing algorithms in a language that I can still read in. So let's figure out how do we need a dictionary first of all. So Racket docs, and here we can probably search for hash map. Is that the right?
The name is hash. Don't make hash, which is mutable.
Make hash. Okay. So define imperative hash, make hash. Okay, so let's kick that to here. And so we need to, what just happened here? I'm command Zing everything and things look weird. Is there an auto formatter for this? Never mind. I'm confused by all the indentation. So we need to call make hash, and we need to somehow define that as D. So we need to say something in the lines of, we need to define make hash.
Not like that.
Not yeah.
In functional programming, you do parentheses, and the first argument of the parentheses is the name of the functions or of the function, and the other ones are the arguments.
Yeah, so I need just an empty dictionary, so I just need to make hash, basically.
And one another important thing, in define, only the last thing that you put in the expressions is the return value. All the above things, all the before things, before the last one, not returned. The return value is just ignored. So
okay,
you need to consider that.
Okay, so
and most of the things are immutable. So
yeah, so what I think about is something. Because we're doing functional programming, we don't even want to probably do that as iteration. We want to do that like in tail recursion, probably, right? And then that way we basically have the
In base Racket, you don't have a while. You only have a for each on the list. So recursion is the answer.
So yeah, let's just iterate over a list basically. So we've got a list.
To iterate over a list.
So we have for loops.
You have for loops, not while, only for.
For loops
the first one.
Oh, Racket base. So wait, so for loops are like part of.
A part of Racket, yeah.
Yeah. Okay.
The base Racket.
For loop. Loop. Iterations and comprehensions. Okay.
Yeah.
Okay, so let's try to figure that out. So we need to make hash, and then we need to pass that hash into the for loop also with the and other arguments probably. Or do we have that like in scope? Do we have the hash somewhere in like scope? Do we like how can we have that?
You can do certain things. You can use let. Okay, you should read about let.
Yeah,
it's really cool. Or you can define it in the global scope, or you can define it in the local scope. But let is the answer probably.
Yeah, so we probably want to do something in the lines of let make hash d. Is that
a few changes? First of all, put round parentheses around the make hash and okay. Remove the d. And now what you want to do is around the make hash you want to put square parentheses. And you want to put around the make hash another round parentheses, and before them you want to put the name of the variable.
Wait, so here? No. I should probably also just read. I should probably just read, right?
Read the doc, yeah.
Yeah. So let's try to actually figure out by reading the docs. Practical. Let's go for practical.
I sent you the local binding URL of Racket. Let and let star. Also.
Yeah.
That is it. So as you can see, in the round parentheses, you define the variable. So
So I need to
hash is a function.
Yeah.
Kind of. So you want to call it like a function in Racket. So
calling it would be like that, right?
Yeah.
Yeah. So let's see, and we've got d make hash, and do we need to say d again? No. Here? No, that does not make any sense. First of all,
what do you want to do now?
Okay, so we created our d.
Now you can do operations with the scope of d. So after that, yeah, just like that, yeah. Now all the operations that you do here will know d.
Yeah. So we can now try to run a for loop. Maybe we will see. We probably need to do that because everything is parentheses.
No, you don't need another parentheses because the
we are
called for.
Yeah. So for let's actually go for that was comprehension. Yeah, comprehensions are nice. Comprehension. So for clause, body or break, body.
So the syntax is much like let. It's really similar.
Yeah. So let's do body for clause, body style. Okay, if this is a good example, then like this is terrible. Probably it's very, very readable for people who actually know Racket, but for people who don't know Racket, this is very busy. Okay, let's try that. So we've got that. We need to pass it something, and we want to say something in the lines of "That's my number." Do we get the index for iterations, or do we need to actually somehow extract that?
You don't have the index.
So do I need to like zip that with some range, or if I want the index, or
no range? You can iterate over two things at the time. Like an example, you can look at an example.
So for I, J, A, B, C. So I'm not sure what's the tick here, but we'll figure out that in a minute. Yeah. So for let's call that nums, and also and we want our I, and how do we have so in range? That's not what we want. We don't have a way to go for the index, or do we have like some kind of like, I don't know, Rust style?
In range. It's like Python range.
Oh, really? Okay. So
kind of, not exactly.
Yeah. So range, and then 0 length nums. How close is this to actually like being true?
Pretty far.
Pretty far is not good. So let's try range.
Length of num is right, but it is in range, not range. Except that it's pretty good. But the for loop is not right. It will not iterate like you think it is. It's not zip.
It's not zip. Yeah. Okay. Yeah. So. Okay. In a minute we will fix that. So this is basically two running indices. This is just two nested for loops right now, right?
Okay.
Yeah, I feel like I want a proper IDE with like.
So you can install the VS Code plugin. It's pretty nice.
Okay, that's good to know. Yeah, I feel like the fact that the editor is not friendly is kind of making me sad. So let's try that. So Racket. So it is installed, and let's open a new file, and let's call that hello. I guess Racket. Or is it not Racket? What's the name of actual like file extensions?
RKT.
RKT?
Yeah.
Okay, rename. no suggestions. Do we need to import stuff to make sure things work? Like, or
You need a lang Racket base. And if you want to use list or a strings function, you need to require list or require a string.
does it do auto
Yeah,
imports
but right
if
now
I just
you're fine. Not like that. Look in the Docker how to.
oh, cheat sheet, probably fine. Okay, so lang Racket. And okay, so this is actually looking like the thing I want. So let's put this one side. And let's literally start with hello world, because right now I do not trust anything. So can we run Racket from here, or do I need an actual terminal? So Racket hello RKT. Hello world. Okay, cool. So this is something I can actually work with. So first of all, you said require Racket list, right?
Sure. Yeah. Not like that, but.
Not like that. Not like that.
Require is like it's function, like. So yeah.
Racket list.
Racket list. Yeah, like that.
Yeah. Can we have more than one function, or do I need now to like everything be in this scope?
No, you can. No. It's require. You can have as many functions as you want.
Okay.
In the global scope.
Okay. So right now let's go back to like whatever that was. So yeah, that's our. I'm quite sure that Copilot will accidentally help me too much. So let's disable Copilot. So the define, let's go with like whatever we have here. Let's copy that, paste that in. And now, first of all, it will be angry at me, which is good. But secondly, we can actually try to make things work. So we've got let make hash d, and now we've got this nested for loop, which is broken. So in order to actually iterate over two things in the same time, where's the cheat sheet? Zip. Do they have zip here? Do we have a better way to?
You can do it as for if you like to.
So I know I can index into the array, but I want to actually like learn how to zip things, because zipping things is actually nice. But
you can do it as for if you like to.
So with for, I mean, wait. So you're saying just do the index and not think about too much, or do you say like actually there's a nice way in for loops to like iterate over two iterables in the same time? So we've got a number, and like that's from the numbers here. Can we iterate over one more thing in the same iteration?
Yeah, you can.
Okay, so let's actually look at that. So for loops. So for list. So we've got for clause repeating.
You just declare another variable like d, like num. Okay, you declared in the for, you can copy it and use in range length num.
But
to not
yeah,
zip it like the way you think. It's you like have two indexes. You like have it will kind of zip, but you have num and you have the other one as the index.
so
For will iterate like you see, not like that. Do enter and copy it and create a new list stream in range with it.
so
Look at the doco. Look at the doco. What they do. Here. You have.
so
You were there. Second. On the example.
yeah.
On the first one. Do you see IJK?
Yeah, but IJK are nested for loops as far as I understand, or are they not? Are we iterating at them?
So when or die only. Stake. So you can look on simpler example, I think. Or you can just open Racket here and run it as the interpreter and check whatever you want.
Okay, so let's comment that out and let's figure out what this actually does.
Just Racket enter.
Yeah. Oh, just Racket enter?
Yeah.
Unbound identifier in A.
What?
So do we need to like let's just copy that because I still cannot write these myself.
Fine, not let.
Can define 1A, or is it the other way around?
Opposite.
A1. Okay, so application, not a procedure. Expected a procedure that can be applied to argument. Okay, so this thing does not look like it's actually... Oh, sorry. Probably this one is the one to blame, right? Yeah.
Sure.
Okay.
Yes.
Yeah.
Remove the when and take just INJ, for example.
Yeah. So
and remove K from the list.
Yeah. Okay, so it is
kind
zipping
zip,
that.
Yeah. INJ and yeah. It does not create a new list. Iterate it.
Yeah. Okay. So so it is zipping over that, like basically.
Kind of. It reminds zip. Yeah.
Yeah. So we've got num for nums, and then we have another iterator here. And we need to give it a name, so let's give that a name, which is I, and then we need to call...
In range or range, what do you want? In range is a stream, range is a list.
So let's just go with range, and then we need length
yeah.
of nums. Is this the right syntax, at least? Now we...
yeah, I think so.
Okay, and we can now close this off.
Now you can display it or something.
Yeah, let's start with display.
Display the function. Parentheses.
Yeah.
And you can do a pair or a list, something like that.
Yeah, so...
no, it will not... It will think that I is an output port.
So we need... Oh, I see. So we need list and then...
Pair, something like that. you put it too much parentheses.
Too many parentheses.
Yeah.
I'm trying to. Okay, so list. Oh, I see. So I just need to pass these as arguments. Okay.
That is fine. So now you can call it.
We need to close. Yeah.
Now you can call it from the. Okay.
Yeah. So let's just now
do some.
Yeah. So two sums, and we can just give it a list of 1, 2, 3. And we don't need the target at this point, but let's just have that.
No commas.
No commas. Yeah, this will take time to get rid of this thingy. So,
nice.
But I do have problems here. Broke its own contract. Oh, that's all right.
Yeah.
We don't care about breaking the contract at this point.
You can delete the contract for now.
I want that in because I want to actually see that what I'm doing actually is abiding the contract. Anyhow, this is actually okay. So we've got 1, 2, 3, and we've got our indices 0 through 2. Cool. So now that I've fumbled my way through making a for loop, and you have suffered immensely, probably. I'm sorry about that. Let's try to make this actually work. So we've got D in our. Okay, so this is the interesting scope right now. By the way, is there like a way to format this so it will not like be insane? The amount of
You need to install a package. So Raku. Go to the terminal. Raku. No. In the terminal, not
in the terminal. So
Raku. No, you have it. It's the package manager of project manager. Raku, yeah. Oh.
Okay.
PKG package.
Yeah.
PKG.
Oh, sorry. Yeah.
Install FMT. Yeah, or you can just press A for
yeah. Okay, I see a lot of scribbles.
So now Raku.
Wait, by the way, I think I just pressed Y. I don't think I pressed A. Is that a problem, or do I need to just let's reinstall that?
I think it's fine.
Okay. So
Raku FMT. The name of the file. No, without a.
Yeah.
Raku, not Roku. So here is a formatted one.
Oh, but it's not writing that.
It's in the out, yeah. So you can redirect it.
Doesn't it have like
just redirect it? It's simpler.
Yeah, but
you can't redirect it to the same file because it's trying to read at the same time.
Yeah.
Or you can just copy it. It's never mind.
Yeah, this is not good UX for a formatter. Hello to RKT, and we probably would need to toggle between them. That's not good. I need to save that one, and now it will work. Okay.
Nice. By the way, this is the only formatter. There is no another.
That's very good. I don't need another formatter. I just want something that's working.
It look even worse after the formatting.
I think this is like it's not looking worse. I think this is a very simple program, and like it's like for people who are used to reading parentheses-based languages, this is looking completely fine. And for us normies who are completely alien to this concept, this is like hard because we're just not used to reading this.
Yeah, I guess, but also you probably need a plugin for like extra colors because this a bit it's a bit bland with all the purple, yellow, and blue.
And blue. So we can probably install something like rainbow brackets. Rainbow brackets, right? Rainbow. But I think this is like not completely parenthesized. So never mind that. I really don't care about that much. I mean, it's enough for me to now like manage the basic thing that we're trying to accomplish, which is we're trying now to like do two things to this dictionary, and then we try to return like one thing, which is a list of two indices.
So now you should look at the set hash.
Yeah. So let me try to now guess, because now this is actually like so we've got probably something in the lines of set dash hash, and then we need or
almost.
what? Almost.
Almost.
Set. So so let's go back to the cheat sheet and hash, and we've got
it's hash set.
Hash set. So you said set hash, and that's why. So hash set. Exclamation mark. So what does exclamation mark say in this context?
I don't remember.
Because so it's like because it's mutating. That's like the thing.
Yeah, I think so. Also, it depends.
Okay.
So yeah, hash.
Yeah, and we probably need to say hash table and then key and then value. So the key is going to be the subtraction of target minus num, and we need to probably have that in an S expression, because this is how or actually probably okay. So this like the language should know to pass that, because there's no other way to like. It would not.
It will not.
So I need to pass. Okay, so is that a way?
No, not like that either.
Interesting.
Minus is a function.
Minus. Oh, right. Because everything is a function in functional programming. Yeah. So minus target num. And now we can move on to like the thing that we actually try to do, which is, and we need to like put the either. So this is the one thing of the iteration, but we need to do more than that. So let's wrap this in another function call, and let's do the other things that we need to do, which is to check if something exists in the hash. So we go to the mutable hash that we have here, and we say in hash, and then we try to do that. So in hash, is that the right one? So observe. So in hash accepts hash bad index v. So that's not the right function. Hash value.
It's probably hash member or something.
In hash keys. What? Wait, for key in hash keys. Oh, so definitely not in. Okay, so in is not the right thing at all. And mutable hash. Okay, so it might not be under mutable hash, it might be under just a regular hash. Right? So interesting. I'm confused. So we've got hash. Let's just go to whatever that is, and we say hash equals hash value, hash kv, test, check, member. Racket, key in hash tables, key. Why is there no like simple like how to like get and set keys from the hash? Like hash set was so nice. Like it says exclamation mark for mutation, and then it says like exactly the thing that I want, which is dictionary and then the key and then the value. Like why is it not as simple as that? Hash tables cannot be equal unless they have the same mutability. Cool. Okay, so hash equal. No. Hash week.
Hash ref.
Ref. Hash ref. Hash table key. Failure result. So hash ref. So it's here, but definitely I would have never clicked hash ref. Like it would have taken me so long to find that. Returns the value for key in HD. If no value is found for key, return failure result. So, okay. I'm surprised. Like this is really like for me, this is not an intuitive name. Do you have any like insights to what am I missing and why is this like not? Let's actually call that HD because we're not in Python land. We're in Racket land. Why hash ref and not like I don't know, hash member, hash in, hash anything else basically?
List is a list member, so I also was confused, and then I looked on the doco and remembered. But
yeah,
yeah,
and failure result. Yeah. So hash ref, and then we can say something like what's the do we need the failure result? Yes, we do need that because we need to now do something with that. Like we need to decide either to. Okay, so we need a condition. Like we need to call a function here, right? Then we need to do something with the result, or this is not the way to do stuff here. Like I would like to return either if it's inside this, then we'd like to okay. I need to go for conditions basically because I don't know actually how to do conditions. So let's find.
So you have a few kinds of conditions. You have cond, which allows you to do only if without else. And you have if, which requires else.
Yeah. Okay.
So, cond is probably your answer for everything. It's also a switch case kind of cond.
Yeah. Okay. So we can then wrap everything with cond, and this is our condition. We don't need anything right here, right? This is.
Not exactly like that. You should look on the doco.
I should look on the documentation. So this is cond. Yes, so it's either okay, cond odd else something. So so we've got that, and if that is the case, if it is here, then we need to return a list of. We'll need to figure out like how to extract that. So wait, do we need to like go with like some kind of
So you should look on the set function.
On the set function.
Yeah. Not on hash set, on set. So you can say, or you can just use let. So it's probably you should use let, but you can use set as well.
I probably don't want to use set then if you say that I'm not supposed to do that.
It's not recommended.
I mean, like mutability is probably not the thing that I want to aim for. So let's try not to do that. I want to basically just like early return now because I only need to return like the list of two indices. So I need to first of all like extract the value from the hash table, and one of them
and the default value can be -1.
Default value of what?
Not an index.
Yeah.
So and then the cond with let's say
let's go back
if it's negative number, and if it's not negative, you know it's what you found.
Cond. So we can just say
you can use if here because you have else. So, but cond also have else, so it's not really better.
Yeah. So we need to say something in the lines of, how do people write this? Like I feel like I'm writing really slow. Anyhow, let's go with negatives, question mark, and then we need to like have this thing, and this needs to be here, and let's close the parentheses correctly. So if this is negative, then we need to hash set.
You can you probably should save the result in a variable with let.
Do I? I mean, I thought.
Otherwise, you need to check twice.
Why do I need to check twice?
Twice.
I mean, yeah, I see that this one. Okay, legit. Yeah, especially if yeah. Okay, let's just do that. So let's literally read let because I can't recall that. So it's here. So I know this is like not formatted correctly, but I need
the code probably.
Yeah. So let bind, let's call that diff. Diff is probably a name of a function. I will not call that diff. Let's just call that x, and we will pass that thing, and then negative x. This is bad naming, but sure. So also hash t, okay, and -1, is that a thing? That's a literal that is possible? Yeah. I don't need to do like a fancy function magic just to get myself a -1. So we've got cond negative x, and then we need to say we want to return.
Just put the hash set though.
Yeah, the hash set. Okay, and then we need to otherwise we can basically
do else.
Yeah. So
round parentheses and else.
Yeah. So
yeah.
Oh, yeah.
Just like they did.
Yeah. So else, and then we can just return our list of. Yeah, this is not going to work. So list of ix. Maybe? And we can now try to figure that out. Let's see if we let's format that because this is terrible. So let's paste that in. Let's pipe that back to Racket. And then it says that it's unhappy because we have unclosed parentheses. So let's figure why we have unclosed parentheses. Yeah, we were missing one pair of parentheses. Okay, this is their doing. This is not mine. That's the way to format this. I feel like I'm missing something here, and that's
Before formatting, you should probably run. I don't want to spoil you. You should run.
I should run, you say.
Nothing happened, so
Yeah. I need to. Okay, so
give it
let's.
a few. For it doesn't return anything.
Probably, yeah. Yeah, this will not work though, because we need something that's, let's go with 4, because we can expect 0 and 2 as the indices here. So, Racket, hello, RKT, and it says bad syntax. And let's figure out what's going on here. So we've got a for loop, and it's iterating over.
The let is problematic.
The let is problematic. So
yeah.
Let's read over the let. Yeah. So we've got let, and we bind x to 1, y to 2, and that's a function call by itself. And let's start.
A function call over.
I'm.
Variable declaration. So you're missing a parenthesis.
Around this?
No, around the round one.
Around.
Close it on the left. To open it, kind of.
Which, say which line at least?
Line 8 before the round parenthesis. Yeah, here you after the let keyword. There.
Yeah. Because I want everything to be in scope. Okay.
Yeah.
Okay, so this is going to now. Okay, so we're letting this.
So now you do delete one of the closing parentheses. Yeah.
This is broken, but I will figure out in a minute where
somehow.
Yeah. Okay, so we've got. So we just created X, and we want this to be open. No, this is actually correct.
Yeah.
And this condition should quit. Okay.
Okay, this is fine.
So what seems to be the problem? Okay, apparently.
Yeah.
Okay. Okay, so let's actually now this is saved. Let's try. So first of all, no value found for key -1. Okay, cool.
Because href you forgot to put the key. You just you're missing an argument in href.
In href, we are missing an argument. You are correct. So we've got this.
No, I.
Sorry. Yeah. I is that. Yeah,
no,
that's
I. Not I. You need a minus. What? No,
I is the right one. I is the right one. Yeah, and it says procedure can be applied to arguments given void. Not a procedure. Okay, first of all, let me just format this for a minute, because this is getting out of hand. Yeah. Okay, and let's figure out what am I doing wrong, because right now, this is actually at this point, we have a basic structure of the algorithm, and I'm actually doing just wrong stuff. So if x is negative, we are setting the hash table with the subtraction of target minus number. Am I reading this correctly? Right? Minus is a minus b.
Yeah, target minus number. Yeah.
Okay, that's very good. And then hash set, we are setting in the key of That's the key. We are setting the index. And now, so this is a function that returns void, and this is actually returning a value. So this is probably not good, right? I need to somehow return something out. Like I need to break out of the loop.
So as I said you earlier, the last thing that you put is the thing that you return. So you can put, let's say, 1 after the hash set, and it will return it. Or you can put void in parentheses, which will return void.
Yeah. But I mean, probably hash set by itself already returns void, right? So let's actually run the file and not format, sorry. Okay, so first of all, let's see where it actually tells me that I'm failing. So it says hello racket to sum. It's not letting me know where have I failed within the function. So that's not helpful. Given void. Interesting. So let's try to read again, like how do we do the for loop? And then we need to figure that out. Okay, so we've got our sequences. We've done that. We've got our expression here, which is let x do something. And right now this condition is, okay, so we are basically in the condition. So how do we break out of the for loop, basically, when we've hit that part? So we can say break, apparently. So else. So for when, unless, do, break clause, splice. Interesting. So the break clause itself is, okay, so we don't actually need the conditions. We can just run this directly through the for loop. We don't need like cont.
Yeah, you can use when. And you have break as well.
Yeah, this is, I was reading about break, but then I understand that basically we can literally run this like that. So we can say now
it's like
for
a filter, yeah.
Yeah, so so we can say now when negative x, right? And that guard expression is probably the same thing. So we can just literally run, like place this here. And then we say break, and then we just return this. Or we actually don't need to do that, right? We just, because like break does not, so basically it's just the else to the when. So so
the
it's
when
even
probably will be problematic. You should probably just use the break.
Okay. So we can eliminate the else expression and just.
But you should set to set a global variable or local variable with the value of the list.
Interesting. So you're saying like I will not. Okay, so I need to do that also here on the.
For doesn't return anything.
Yeah. So before the for, we need some like result variable, basically.
Kind of. You can save it in the let.
So here. Interesting.
No, not in the for, but like where HT is.
I see. Okay, so yeah, we can just say result, and this is going to be a list of.
Not like that.
Yeah.
You can just put an empty list. Okay, like that.
Empty list also. Yeah, sure.
Yeah.
Do we need to call that or just?
No, it's fine like that.
Yeah. Okay. Okay, and we can just say. Okay, so here we can probably say set, and then result, and this is the list that we want to set.
Yeah, sure. And then you should return it.
Yeah, so
by putting the result in the end of the define expressions.
Yeah.
Just result. After the let, enter result.
After the let, enter
the main let. Line 5.
Yeah.
Yeah.
Yeah. So
the last parenthesis. Yeah. Enter result. Yeah.
Yeah.
Sure. And you should display. Okay. What is the problem? Because it doesn't know him. So put it in the result, in the end of the result. So the result will return it to the define, and the define will return it.
So here.
Yeah, I think so.
And it says still a procedure that can be applied to arguments, void, context. So first of all, we've got two sums. So we define contract, two sums, blah, blah, that's the contract. And then we say, yeah, let HT. Wait a minute, let's just reformat that because okay, so I was not that far from the actual thing. Okay, so we've got our hash table, we've got our result variable, which is an empty list right now. Let's remove the contract. Let's see if that somehow is breaking us. Probably not, but do we need to do anything else, like in the lines of making this work? This should just work, right?
No, let's try.
So the fact that it says given like void.
Probably a problem with the for or the cond or something like that.
We still need to break out of the for correctly. We haven't done that.
We can do
because
do it later. It's not so important right now.
So let's see, hash ref -1. If x negative, cont x negative. Is this correct?
I think so. Yeah,
okay.
Wait a minute, the hash set. Yeah, should be fine.
So let's actually make this list just to be sure. Let's just put like some sentinel here just to if we comment out everything, I really
was it probably a problem with the parentheses, so
yeah,
probably
yeah. Let's just let's start easy. So yeah, result. Let's just make sure that this works as we expect. Yeah, 1, 2, 3.
Nice.
Okay. So we can now try to figure out what went wrong with the for loop. So how many parentheses do I need to open? I think okay, so wait, I need more one more parentheses, so that's one. Okay, so this for loop right now should not break anything. This should just iterate and then do nothing. We should still missing body expression. Okay, I can get that. So let's just put an empty body expression. Is that like a legal thing? Illegal empty application. Okay, so let's just return 1. A for loop cannot return something probably, but yeah, okay, so expect a procedure that can be applied to argument given 1.
One is not a function. So
I just okay. So let's just go with.
You can just return 1. You can just put 1.
Oh, so nothing like okay. So not a function. Yeah. Okay. So this for loop now, if it returns something, then it's kind of working. So that means we can actually like return result also if we want. So if we let's just make sure this. If we just put result here, this should now return 1, 2, 3. It does not. Which means for does not actually propagate the return type.
Yeah,
the return
that's
value.
why we set.
Yeah.
This was you set.
Yeah. Okay. So now let's try to make sure everything here is working. So we've got now. Let's let x again. Let's just do list 2, 3, 4. And I know. I'm working towards that. I need to convert that, and we can now within that we can call set result x, and this probably needs to be set like that because this is how mutability works. And this should now be 2, 3, 4, and it says. Bad syntax, not an identifier or expression for binding at x. And what have I missed with the let expression? Let
parentheses.
Parentheses
around.
Yeah. So 2, 3, 4. Okay, so now we can try to push things into. That's not what I. Okay, and let's put the parentheses here. And we can now put things inside this let. So first of all, this now is instead of that, let's make that #t inside the function call. So yeah, I know this is the incorrect type. I just want something that works. Or is Racket dynamic and allows to change type? Wait, missing pair body, and it says that let x.
You don't have a body for the let. You can just put void.
Yeah.
Void
Okay.
in parentheses, something like that.
Yeah. Okay. Okay. 2, 3, 4. That's not good because we haven't set. Okay. Sorry. I wanted to do the set result x just to propagate that out. -1. Awesome. So let's try to push this now forward. So we are in the for loop. Are we? We are not. We are. Okay. So let's try to put, actually, I'm just making sure like things work as I expect them to. So this should now be the last element in the list. Yeah, 3. Okay, awesome. So we are iterating, and we have our x, which basically is querying the hash set every iteration. So now that we have that, we can write our conditions. So let's start with cond. Then we say x is negative. So let's actually have that exactly like that. And instead of hash set, let's actually set the result, and let's return that just to have that work. So let's just go with set result, and let's just make sure that we have our subtractions. So probably something's broken, missing ending of this scope, and also this one. Yeah, that's the right one. One more parentheses. One more. No. So, sorry, cond function call. Yeah. 1. Because, let's see, we have x was negative, so we did set result to the last
index
target.
of 3,
Yeah. So it's last target. Yeah, the difference is going to always be 1 here, because we always have 4 minus 3 basically. Okay, awesome. So this is actually working. So now we can actually have our hash set. With that, this is confirmed to be working, and we just need to close up this, but we don't need to do that yet because we want our else block. So in the else block, we want to say, so we have to break, because otherwise we basically set.
If break if result is not empty, or you can break.
Yes. So we have to break before we do this, because we must not iterate after we've done that first time. Okay, so this should work, but we
But it will get the last combination.
Yeah.
The first one. So.
Yeah. It says unexpected, so probably. Yeah.
Yeah, you should really be careful with that.
Okay, 2-1. Is that correct? Indices 2 and 1 definitely do not add up to 4. So it's not. Is it I and X? It should be. I think so. Like if we go back to the actual Python implementation, yeah, it's target subtracted by a number. So, sorry about that. So we actually don't need to set X to wait. So target minus number. Yeah, so we've got that here.
HT in the place of num, not I. In hashref. Line 7.
Yeah. In line 7. HT in the place of
num, not I. 7, one above.
You are correct. Right. Yeah, you are correct. Yeah, okay, that was an algorithmic bug, and now should be 2-0. Yeah, okay.
Yeah, nice. You should swap them. So,
yeah. I mean,
doesn't really matter.
Yeah. That's not the okay. So we've done a basic lead code, like the most easy lead code problem is now working. That was
kind of.
I mean, we've got a lot.
Add the break, but kind of.
Yeah, so let's actually add the break because we don't want to. So first of all, so how do we add the break? So this is our for loop. So probably something in the lines of here. We need to say break. What was the syntax? Break. So for almost. So it's break, and then we do a guard expression. And the guard expression, because up until this point I'm not sure what a guard expression is, but just an expression. Okay, so the guard expression is this list should be empty. So we can probably say something in the lines of list empty?
Empty, just empty, I think.
Empty.
Like that? I think so.
So I want not empty.
You don't not. So it's like Python not, but as a function. But you need to nest it. Need to be nested. First, you call not on the like that.
Okay.
And empty on a result. Probably.
Not empty result. Okay.
Yeah, something like that.
And let's run Racket. And it says
the break is not in the right.
Probably. We can actually
be right after. Yeah, here I think.
Yeah, and let's just maybe format that. Okay.
Yeah, nice.
We haven't broken anything.
I can test it. Good.
Yeah, we can test that directly in the...
Yeah, we can optimize it more, but it's pretty nice.
I mean, optimization, the actual optimization will not come from me like optimizing this toy example, but okay, so we've got here, I think everything. Run.
Is a parenthesis right? Probably, yes.
Accepted.
Nice.
Yeah. Okay. So this seems to be actually working. Let's actually run that through like the full test suite that they have locally, and do they not show me like whether this actually succeeded? Okay, never mind. Okay.
No, it should show you. I think maybe you need to raise the bottom bar a little bit.
Oh, accepted. Status a few seconds ago.
Yeah. You can see your result in percentage of people.
Yeah, I don't think this is going to be like beats.
It's nice.
I mean,
pretty good.
I mean, yeah. By the way, I think we can like probably do a lot better without like doing mutable stuff here. Like the fact that we're
probably.
Yeah, and not doing mutable stuff is actually probably like the very strong point of the language. So we might actually want to do that. Anyhow, this actually was nice. Like I really enjoyed the fact that we actually got to a working solution. It took a little more than I thought, probably because I was kind of like being lazy about not reading the docs fully, and actually trying to understand the syntax. But because first of all, like I'm totally baffled by the amount of parentheses, but I like the parentheses are like okay, the round parentheses, but the square parentheses I still like not fully get. But probably this is so I interpret like the square parentheses as I bind this name to whatever something here, and like the fact that here's an iterator, that's a little bit confusing because it relates to the for loop here, and here we are binding this name to this expression, to the result of this expression. So like I still need to think about it a little bit, and in the condition like the square parentheses also behave a little bit differently. So also like I'm quite surprised here. But like now that I will read more Racket, I will not be totally in shock. So if I need to actually read this line now, I can kind of see what's going on here, because I can actually see that this is a for loop that iterates over ij and k in unison. By the way, what is this like hash? We haven't seen this hash symbol
True
yet.
and false.
Hash true, hash false. Okay. And how come it's okay to have not equal lengths of iterators here? Like
What do you mean?
this is a 3-element list. This is a 3-element string. This is a 2-element boolean.
It will take like zip. It will take the shortest.
The shortest.
If we have two,
Okay, so it will stop at the shortest sequence.
Yeah,
Okay.
like zip and Python. So yeah.
Okay, cool. By the way, thank you very much, Idan. I really appreciate that. You stick to the bitter end. And I will update this. I will upload this unedited to YouTube, if that's okay by you. And if not, then let me know, and
Yeah,
I will
sure.
cut some parts out if you have something that's important for you to cut out.
האנגלית שלי כנראה כדאי שתחתוך.
That's all right, but I think your English is fine, and no worries about that. I don't think this video will get a lot of views, because this is like the more mellow, chill stuff that I do. That's long form is like not for everybody, because as you can see, like it's basically me grinding my teeth, trying to learn something that I'm super like foreign to, because yeah, I mean the fact that like everything is a function all the time, and like there's so many parentheses is like super.
Racket, we most of the time we use recursion. Here you chose to use iteration, but
yeah. So
in
actually,
our case, it would be really great to use recursion.
Okay, so actually maybe let's try to implement that
You can
again.
rewrite it in recursion now.
Yeah.
Much shorter, much nicer, and much faster.
Yeah. Okay. So let's actually do that. So this is probably should be quite fine. So this is to some iterative.
Yeah, you can
iterative.
have functions, so you can define a sub-function.
Okay, so we can define. So how do
Another
we?
function is the define. Yeah.
Yeah. So first of all, so we need. How do we do that? So we need here define.
Define, yeah.
Yeah, and now another function.
Subject, for example, I don't know.
What
The
did you
first
say?
argument is a name, and the other is the name of the argument. So
So
this is the name of the function.
yeah. So but like let's try to think about this in a recursive fashion. So we need to pass. We always need to pass the dictionary itself, right? By the way, how does the mutation work in that sense?
What do you mean?
We need to like pass the hash, because we need.
You can define the hash as global as local variable in let, and define the function in the let.
Yeah. So okay. So let's
something like that. Yeah, it will be better. And,
yeah. So this is the
use tail for the list, or CDR, or something like that, to take only part of the list, only the.
Yeah, but basically this is
of the list every time.
Yeah.
Each time.
Yeah. Okay. So we've got our to-sum function, like the actual recursive one, not the one that needs to get like a sublist, and the target is still going to be the target. Actually, we have the target in scope. We don't need to pass that. We just need to pass the sublist every time. And we don't need, and we need to go like this and actually have an expression, right? And what do we do with the sub? Okay, so what we would like to do is, first of all,
probably start with a cond.
With condition sounds like the right thing. Yeah.
To a stop condition.
Yeah. Okay. So
if sub-L is empty, you want to stop it.
Yeah. So empty. sublist. We can just how do we?
But you can raise an arrow. I don't know.
I mean, the list here could be empty. No, it could not. So how do we raise errors in the?
I do not remember. Actually.
Okay, so let's not.
Check it.
Yeah. There we go.
Never mind. Okay.
Yeah, and now let's go with.
But the code is not right.
The code. We need to wrap that with this. And now we go with else, and then we say. So we have an element in the list. We need to do another condition, which is. Okay, so we've got two branches here, basically. So we've got the branch of setting the hash, and we've got the branch of checking the hash. So first of all, we need to check the hash.
So you could use let here as well.
So let's bind that to.
But it's not right. You need to warp it. Not all the. It was okay.
Let and then
to warp the square parentheses. You need to warp with round ones.
Oh, this one.
Yeah.
And now we
define hash ref.
So x equals to hash ref hd and sub. Do we have like a last element or something?
Car. To get the first element is car.
We need
CAR. And if you want to get the second element, it's CAAR. And the third element is CAAAAR. Really nice.
What? Why
if you
do
want to get the first element, it's CAR. If you want to get the second element, it's CAAR. If you want to get the third element, CAAAR.
I'm so confused. But sure, okay.
Just look at the docker on car.
I fully believe you. I just but we want
you
to.
Can try it. Just run Racket as interpreter in the terminal. Enter. Just Racket. And now let's create a list. I don't know. Define x list. Whatever you want. You can use range. For example, use range.
So define
x. No, without parentheses.
Oh, so just
x. No, the define with parentheses.
Okay.
X and let's say call range one now. I don't know. Range till 20. I don't know.
Yeah, 4 is enough for this.
Now you can print x.
Now
you can do car x. Now you can do car with. CA. It should work like that. What is the problem? It probably wants you to fold it, so you should call fold. Never mind. You can use take right or a list ref. You can use the list ref here.
But
you need to call fold. Never mind it.
So CAR
list ref.
So fold like that?
I think something like that, Let me check.
Undefined reference. Really not important.
I can check it real quick. Let's see. Never mind. I don't find it.
So first of all, this should just be now. So negative of href htx. We need let x for that.
Car CAR, it's for sub list, not for the actual list. It's for my mistake.
Okay. Never mind. Okay, so
you can just use a list ref. It's working.
Anyhow, okay, let's just go back to actually writing this. So we don't want else, we probably want to pattern match on more things, right? We can just do this, right? And just instead of, we can just immediately say if basically negative on href on this, right? We don't need x.
Do you need x? I don't know. You can use x if you want to. I don't know.
I mean, it's the last element, and then
work the code with let. I don't know. Whatever you like to.
Actually, by the way, we probably want also the index. We haven't like having I here is going to be useful.
We didn't define toSum as function. Now it's kind of a variable.
Oh, so it's supposed to be
before sub n. Yeah. Before toSum. Yeah. After sub. Yeah. And the closest ground parentheses after sub n.
Here.
Yeah. Sure.
We don't need this. Okay, so we've got toSum. Yeah. This is going to be basically.
You can know the index by subtracting the length of sub L and the length of nums.
You are correct.
Yeah.
You are correct. I mean,
how does it calculate quickly the length of the sublist though? Like if I'm always giving it a shorter list by 1, does that mean that it's always like updating some sort of length?
No, what we mean is basically we can just subtract the lengths of each, and that's going to be quite easy.
No, what I'm asking is how does it, if you're always mutating the list, so how does it know quickly?
No, the list
we're not mutating it, we're passing slices. We're going to pass a smaller view of the list into the recursion.
And so the view is holding like a start and an end, so you can.
So we only have one object here. We only have the nums list. We are just passing in the different slices of that list with no copies, hopefully, into the runtime. And the internal, let's call that, I don't know, impl something. The actual implementation of the algorithm actually only takes like a sub list of the actual list. Hopefully, we will see in a minute.
When you call length on the sublist, what you get is like the last index minus the first index.
When we call length, no, we are not. We are going to literally subtract the two length calls of each list. We can probably cache like the length of nums here because it's immutable, but also like I believe the runtime knows it's immutable, and that's why it will probably cache that for us. Because that's why immutability gives us.
I guess I'll see soon.
Yeah.
What's going on?
So we've got if it's negative. So in order for that to be negative, we actually need to pass -1 here to a href. So if yeah, and this is the last element on this one. Yeah, that's the first element on this one. Yeah, that's right. Okay, if it's that,
you could return a void if you want to.
Here? No.
No, instead of -1. And void question mark. No, void in parentheses.
Oh, right.
And void the question mark to check if it is void. I think so, if I remember correctly.
Yeah,
No,
I'm not void. Anyhow, that's good enough for now.
I remembered correctly.
Okay, cool. Okay, so now we can continue with the pattern matching. So here we have, let's see, it's now, if it's done, if it's not void, then what do we need to actually do? We need to do something with that.
Okay, we need to use the function take right from list, from Racket list.
So take right Racket.
Take right Racket,
yeah.
So as you can see, taking the right. So yeah, that's kind of what do we want.
So yeah, take right. Take 2.
Or we can use CDR if you want to.
What's
CDR might be better.
So
because we want only one. So CDR might be.
Yeah. So CDR is
CDR,
to return the second last element of pair P, but CDR would need a pair specifically.
No, you can use. Check me. Check me on the Racket interpreter.
Yeah.
Just
So
CDR range. I don't know, whatever you want.
Range.
Parentheses. Yeah. So it's starting from 1.
Yeah. Okay.
Yeah.
Awesome. Okay. So if it's void, actually, so it's not. We don't want to return void here. So this is our actual recursion. Like if So here we should go. Actually, our implementation, our function call. We are in that. So impl. We need a better name for that because this is like the name to_sum is taken for the actual.
CDR.
Yeah, and now we need to go CDR and let's take our sublist. And I think that's it. No, we need to actually like put stuff in the hash.
We just want to return it. And in the else, we just want to return to the href. So, yeah.
Yeah, okay, and the else now we want to actually...
So that is why we might want to use let. So, not call twice.
Not call...
It's not so important. Whatever you want.
Yeah, okay, so first of all, like let's clean this up because there's a lot of crap here. Okay, so else. So what would...
If it's not void, it's not empty, we just want to return the href.
Yeah.
You can copy it, you can use it. Yeah. But in the href, you are missing a parenthesis.
In the href, we are missing...
Yeah. So, the parenthesis is too off. So you need to make it closer, and in the default element, you want to return void.
Wait.
So right now, the default element is the call to the recursion.
Yeah, okay, so, but we haven't done the actual like mutation of the hash at no point here. So here we need to actually do the hash.
Only.
No, but we want to do like the hash set.
No, we want to do the void here, and after that the hash set. Because if we don't have the element, it will return void, and the question mark will return true. And after that, only after that, we will be allowed to execute as many commands as we want after the Boolean check.
Yeah. Okay. So
almost before, just before the closing square brackets.
So
you can put as many operations as you want.
Oh, so we can do
set and the recursive call.
So here we can actually run. Okay, so hash set.
Yeah.
Is that a thing? Like I'm.
Yeah. We use it. You can look at line 10.
Okay, so hash set, and then we just.
You can just copy it. Almost.
Let's find that. Let's find that. So we've got hash.
Line 10.
Yeah. So yeah, we don't have
You just need to calculate the index.
Yeah, so this one is going to be the subtraction of length nums and length sublist.
Yeah.
And we need our recursion.
Yeah.
And yeah.
With
so
CDR. Yeah.
not hash
So
ref.
why
sorry. Wait, why is this hash ref? This wasn't supposed to be hash ref.
Yeah, it should be a hash ref.
Wait.
Just
sorry.
want to return the value.
Yeah. So yeah, here is impl with.
Not like that.
Yeah. You are correct. Yeah. Impl with CDR.
Of Sabel.
Sabel.
Yeah, it should work, maybe.
And we should only now call that externally with impl nums.
Not like that.
I will learn at some point. I will learn. And let's just make, we just need to
You're
do
missing
that.
a parenthesis because it is red in line 14.
Yeah. And we need to do this call with the scope of define. So here.
Yeah.
I think this should maybe work.
Maybe. Exit, but exit in a Racket way. Oh, just like that.
Control D is usually working. Oh, let's just undefine this one. And let's figure out. So syntax expected close line 28. Unbound identifier num. And it says num.
Num is it's car of Sabel. Maybe if you want to refactor the code later, you could use let. But later.
Yeah. So car Sabel. Yeah, we're using car sub L in 2 places, 3 places.
Three.
Yeah,
maybe later. So
yeah.
Let's fix this one.
It
So
says.
what is the problem now? It's probably the code.
So const error, const void. So this is actually executing. Wait, this is probably not correct.
What is not correct?
It had a parentheses on. These pair of parentheses were not correct. Yeah. 0. That's probably. Oh, we need to return an array. So.
So we need to return the index. So the index is the length of nums minus the length of Sabel. So we might want to put it in the let as well.
Yeah, so let's actually do that. So we need to say.
Yeah, we need a pretty. Yes. So we need 3 variables in the let. The value of the hash ref.
Yeah.
The index and the num.
Yeah.
And
so we've got
one parenthesis around the. Yeah.
Around all of these, right?
Yeah.
Okay. So we've got
num, I, and I don't know.
So wait, num is car sub and we've got I, which is
and maybe key. I don't know.
Key is nice. Key is nicer than I. You are correct. And this is going to be this key, I think. Let's just replace that.
Yeah, that is good. Okay.
And yeah.
And the last now is the last maybe value, the last one.
And so first of all, like
Be the hash value.
The hash value. So yeah.
Yeah.
So I'll test basically.
Yeah. Okay. Whatever you want. Parentheses. Yeah.
And we can now say
Replace
if
it with test. Yeah. Just test.
void test.
Since you deleted one too much. Yeah.
Yeah. Okay. So we've got.
And in the else in line 27, you can replace it.
So that's.
So do you want to see another cool trick?
Yeah.
Okay. If you want to use one of the let variables in another let variable, you need to use let כוכבית. How do you say?
Let star.
Yeah, in let star. Okay. So yeah.
Let star. Yeah.
Yeah. If you want to use let's say ph in x or you see they use x and y.
Yeah.
So you need so you can use just now in the test.
So
instead of calling car sabel again, you can just use num.
Yeah, so I need to call that to let star like that, and then I can just use num right here.
Nice. So that is it.
Wait,
I think.
Let's just make sure the algorithm actually works. So
in the else we need to return.
So we need to return a list here. So list is going we need two things. So we need our key
and num.
And num. So key num.
Let's test it.
And let's see, that returns impl of CDR sub L. Yeah, I think it should work.
Yeah.
And it says closing parentheses. So let's figure out what went wrong. So this parentheses closed the let here, but we are missing one more closing parentheses, I think, here.
In the hash set, we can refactor it.
Okay, so 2, 3
line 24.
So first of all, line 24 hash set.
Refactor it a bit. So car sabel it's num. So we can change it.
It's car sub L. It is num.
Okay, nice. So,
but it's still
not working.
It's wrong right now.
Let's see why.
Okay, so what do we got here? So we are defining this one is always the leftmost item. And here we are, first of all, let's make sure we are not iterating on nums every time, right? Nums is only defined here on as our key.
Yeah.
So the key should be at first 0 because we are passing nums, and then it should so the iteration seems to be right. Our item, let's just call that item. Item is nicer than test. So if the item is void, and what is the item? Item is lookup of that number. So this is not correct. We should have looked for the difference, right?
No, for the number. Just
right, because we are looking because
before what we did.
We have subtracted.
Yeah, in the hash set, but we search for the number.
Did we hash set correctly? Let's see. We hash set for the difference. Yeah, I think so. Wait.
The key. We need the key. Yeah.
Yeah. So wait. So this is why I was nicer than key because
it should be key and item, not key and num.
Should be key
and item, not key and num. In 27. Line 27.
27.
Yeah. Key and item.
Key and item.
Yeah. Now we should walk.
Okay.
And why did you else?
Yeah.
Now you can try it and ta-da!
Yeah, and just replace item and key. Yeah.
Key, but although that is perfect. And now it will have much better performance.
So let's actually drop that into these.
Let's see before what was the result before.
Okay, so runtime 200 milliseconds, which is quite fast already, I must say. So like not crazy slow.
Yeah, let's see.
And we can just now run that again. First of all, let's just make sure that this actually passes the tests. By the way, 127 megabytes, that's like crazy. That's a lot of RAM for like this small of a function.
Yeah.
And let's submit that again. And we actually have the benchmark here, so we can actually make sure that this is actually working. And accepted.
But it's worse.
It's worse.
Yeah, why?
Huh. Same amount of memory.
Because we calculate the length of RAM every time.
So this is what I thought.
Take it out in LED. I can see on a few optimizations.
Sorry. This will probably help.
Maybe that.
Sorry. So this let's
in the lead code.
Yeah, in the lead code. Let's just paste that. And
it wasn't there before, I think.
It wasn't? Oh, it was not. Okay, it was not. So
just need to see. Yeah, I don't know.
Let's submit that again, because sometimes things just take more or less time. But no, it is consistently slower. Interesting.
So maybe mutable stuff. It's not.
I think the only mutable stuff here, the only mutable thing here is the hash set, and it's in scope.
I mean, we're slicing the list tons of times, so.
Yeah, but is this like copying the list, or is it a reference in the list?
Copying it. I guess. I don't know. I don't really know. Maybe it's referencing it. I don't know.
Interesting. But now we're in the realm of actually trying to optimize, which is nice. Like the fact that we are like we've crossed. Sorry about the flickering stuff. The fact that we crossed like the barrier of like not talking about the language, but actually talking about like the performance of it. For me, it's like an achievement. So awesome. I think I will not try to optimize that now because it's getting late and we should all go to sleep. So thank you very.
So we could do some stuff, but it's pretty nice.
I mean, thank you very, very much, Idan. Like, I really enjoyed you walking me through this seemingly simple example, and we actually like had to think about performance. We had to think about memory. We had to think about like how to write things that are like a lot prettier. Like, if we look at this actually looks nice. This does not look ugly. I can actually read this and like see what's actually going on here. Compared to, I don't know, the mess that we had here, which I don't know what we actually, like I know what we did, but I mean, this was not as readable as actually defining this as a recursion.
Yeah.
So thank you very much.
It was fascinating. This awakened something in me that I'm not sure I want to explore, but it was very fun. Thank you.
Yeah. So good night to you all. And I don't know, see you in the next video. Bye bye for now.